While all engine intake systems contain a fresh air duct, air cleaner, and intake manifold, most diesels add a turbocharger and charge air cooler. Some components are controlled by PCM to optimize air intake for operating conditions and driver demand. Let's look at each of these systems and how they enhance the diesel engine. Select any highlighted component to learn about its role in a diesel engine. NOx forms when there are very high temperatures in the combustion chamber, as seen on the right side of this graph. The exhaust gas recirculation, or EGR system, introduces precise amounts of exhaust into the intake air charge. Exhaust gas is inert and non-combustible. When exhaust gas is introduced into the cylinder, it reduces combustion chamber temperatures, which dramatically reduce NOx formation. The PCM regulates turbocharger boost pressure by controlling the wastegate valve. When the wastegate valve is open, some or all of the exhaust flow bypasses the turbo and travels directly to the exhaust system. This results in decreased turbocharger boost pressure. The PCM senses boost pressure in the intake manifold and back pressure in the exhaust system and controls the wastegate to avoid excessive boost or back pressure. In a normally aspirated non-turbocharged engine, air enters the engine at normal atmospheric pressure, which is about 14.7 psi. Turbochargers boost the intake manifold pressure so there's extra pressure to push more air into the cylinder. This process allows the engine to burn more fuel, so it acts like a much larger engine. Depending on turbo design, boost varies from about 5 to 50 psi, but most turbochargers provide about 15 psi over atmospheric pressure, which causes an engine to take in as much air as an engine about twice its size. Diesels flow large volumes of extra air that's also useful for in-cylinder cooling. Turbochargers boost air pressure, which is good, but the process also heats the air and reduces its density, both of which reduce engine power. The intake system directs the heated, high-pressure air from the turbo through a charge air cooler that cools the air before it enters the engine. Cooler, denser intake air increases engine power and efficiency, while also helping to reduce piston and exhaust gas temperatures. A single turbocharger cannot cover an engine's full RPM range without compromising some part of the range. Different manufacturers address the issue in a variety of ways. One way of producing boost throughout a wider power band range can be obtained by using a dual turbocharger configuration. One such example is where a small turbocharger and a large turbocharger perform two-stage air charging in parallel. At low engine speeds, the small turbo charges the intake manifold. At mid-range engine speeds, the small and large turbo work together, transitioning to only the large turbocharger at high engine speeds.